Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 6, Union Algorithm. Previous to this video, we already discussed about what is disjoint set. Disjoint set is a set where you find no common element. Let us assume that two sets were there, Si and Sj are said to be disjoint sets. When S1 intersection S2 is equal to pi, no common element will be found in between two different sets. Then what about union? Si union Sj is equal to all elements of X such that X is either in Si or Sj. Now, assume that there are two different sets. Look at the down. S1 set, S2 set. S1 and S2 are disjoint sets, correct? Yes, because you find no common element in these two sets. Hence, S1 and S2 are disjoint sets. Now, let's see what is an union algorithm. Union algorithm is one of the basic operation which can be performed on disjoint sets. Let us assume this is what one universal set or one basic set. So the set is consisting of 1, 2, 3, 4, 5, 6, 7, 8 nodes. So this is what the graph. This is what the graph. In this graph, you can see the edges in between 1 and 2 node. So my first edge is what? 1 comma 2. My first edge. So I'm taking out 1 comma 2 from the main set. Now I'm dividing it, calling as S1 equal to 1 comma 2. Now, and my second edge is 3 comma 4. That is S2 is equal to 3 comma 4. Now I'm deleting from the mu. Now look at. So here one set will be constructed as a graph, keeping in mind first node is the parent node, second node is the child node. Underline this point that there is no mandatory rule that always one should be a parent node. It can be 1, it can be 2. Parent node can be 1, parent node can be 2. So I am taking 1 as my parent node, 2 as my child node. So this is the graph for this set. Now for this set, 3 and 4 is the graph. Now when you look at 1 comma 2 and 3 comma 4, these two are different edges, correct? If you wanted to form or draw a edge in between 1 comma 3, 1 is belongs to different set, 3 is belongs to different set. But I wanted to draw a edge in between of these two. When you would like to do this, you can perform union operation. Union operation is required when it is required to form an edge or to have an edge in the graph. Now S1 union S2 is what? 1, 2, 3, 4. This is what graph. Now look at. Now 2 comma 5 is having some edge. Acha, we forgot this. 2 comma 4 having edge. So 2 comma 4 in the union list it was there. Union is what? Union S1 union S2. I am naming as some S5. S5 is equal to 1, 2, 3, 4. Now 2, 4 are individual nodes wanted to draw a edge. So 2 comma 4 are in the same set. So union operation is not required. Now come to this. The next edge is in between 2 comma 5. 2 where it is in S5. 5 where it is in S3. Now when you wanted to draw a edge in between S5 to S3. Now what we have to do? We have to perform union operation. Now when you perform union, what it becomes? 1, 2, 3, 4, 5, 6. So union operation is what? When you wanted to draw an edge, if those are not belongs to same set, then you can have union operation. Now, union algorithm is this. Simple union algorithm and the weighted union algorithm is also there. Now, let's see. P of I is equal to J. I told you this. When you are taking S1 is equal to 1 comma 2, now this can be a parent, this can be a parent. That means parent of I is equal to J. Parent of I is what? 1. 1. Parent of I equal to J means parent of I we are giving to J. That means 2 parent is 1. This is what simple union operation. Now there is one more union which is weighted union. So weighted union is what? We will be having something like this, right? Just before we were seen in your this thing, that 1, 2 and 3, 4. We assume that this is what the some set representation. Now, so when I wanted to add 5 over here, 5 will be kept here. Now there will be a question. Why 5 came to this? Why not 1, 2, 3, 4 graph go there? The question is, it is a weighted union. Weighted union is what? When this bunch of nodes are high than this, then this will get part into this. That's what we wrote here. Temp is equal to Pi plus Pj. When Pi is greater, Pi is equal to J. When it is not, that when it is small, then P of J is equal to I. This is what weighted union. The name itself it tells. That individual sets will be added with the based upon weighting rule. So this is about union algorithm.